For years I've wondered how drywall compound would work. I thought, after all, it's easy to sand and it sticks to everything you don't want it to stick to. But typical drywall joint compound is made to set up only through evaporation. So even when it's set, moisture makes it unstable and softens it. If you've ever used it, you know that it'll be usable for a fair amount of project time if you just keep it sealed. However, setting type compound is a plaster. In this case, water's added to the powder, which in turn starts the process of crystallization with the liberation of heat. The result's stable and resistant to the effects of moisture. You can see on the label that it's non-shrinking. Here's an excerpt from a paper on setting type compound. Setting type joint compounds are plaster of Paris based and hardened by chemical process and evaporation rather than solely evaporation, giving an advantage in filling holes and gaps that would take many days to dry out, with shrinkage cracks if using the drying type compound. Another advantage to setting type compounds is that after curing they do not soften when wet, thus they're better for moist environments such as bathrooms. Setting type compounds are available in times ranging from 5 to 300 minutes, and finish characteristics from tough and well bonded to soft and easy to sand. After setting, any leftover cannot be resaturated and reused. The idea that it's plaster of Paris is very appealing. For many years I've used dental stone to fill wheel wells of in-flight models that were supplied with ill-fitting doors. The doors in this Tamiya P51B were done in dental stone 15 years ago. The process took minutes, but here the stone's held in place mechanically with undercuts because the stone has no adhesive quality. However, the drywall setting compound does stick to stuff. To give this material a test for stability and adhesion, I gave the demo fillet to the Scale Model Workshop Labs for evaluation. To simulate the actual application on the A26, the area was given a coat of automotive primer. Once good and dry, the sample was placed in a 175° Fahrenheit oven for 20 minutes. Then it was placed in a freezer for half an hour. At this point, everything seemed to be stable. Finally, the sample was subjected to the SWIG 20 compression tester. Here's the final result. As you can see, the extreme crush has opened a fair amount of the joint at the point of maximum flex along the fuselage. However, the wing joint is still perfectly intact.